Friction. Friction is an opposing force which comes into play when one body actually moves or even tries to move over the other surface of another body. So, according to the classical theory of friction, the roughness of the surface was responsible for the friction present in it. But according to the modern theory, the cause of friction between the two surfaces is presence of strong atomic or molecular forces at that point of actual contact. Frictional force is a self-adjusting force. We will see this with an example later. We should know about limiting friction. So, the maximum value of static frictional force which comes into play when a body just begins to slide over the surface of another body, that is called as limiting frictional force. You have to remember it is the maximum value of static frictional force. So, it is found that the limiting frictional force Fs is directly proportional to the normal reaction R. So, we can write Fs is directly proportional to R, that is limiting friction is directly proportional to R, reaction force. So, now I am using a constant F is equals to mu s into R. So, what is mu s? Coefficient of static friction. So, from this I can write coefficient of static friction, that is equals to Fs by R. Okay, that is frictional force, static frictional force, limiting friction by reaction. This is what is about limiting. Now we will see about the kinetic friction. This is also called as sliding friction. So once the motion starts, the frictional force acting between the surfaces decreases, so that a smaller amount of force is required to maintain a uniform motion. The force acting between the two surfaces in relative motion is called as kinetic friction or sliding frictional force. This is actually lesser than the limiting static friction, Fs. Again, kinetic friction, that is proportional to the reactional force. So, from that we can write the coefficient of kinetic friction. So, mu k equals to Fk by R. Now, if we see the coefficient of static friction is always greater than the coefficient of kinetic friction, because once the motion starts, inertia of rest has been overcome. So, that is the reason. Now, we will see about the angle of friction. Instead of limiting friction, the angle which the resultant P makes with a normal reaction R is called the angle of friction theta s. Now let us consider this example. So this is a body. I am applying a force F on this direction, on the towards right side, and the weight mg is acting vertically downwards and the reaction force is acting vertically upwards because of the floor. This is a rough floor, okay, so there will be a reaction present in it. So if I am making some applying force F on this direction, then the roughness prevents it, so it tries to create an opposing force, that is what is friction, Fs. So if the motion is towards the right side, then the friction will opposite. So the friction will be, the direction of frictional force will be towards the left side. Now if we take the resultant force, here the resultant force P, that is because of this reaction force R and this frictional force, okay. Yes, so that is the case. And this theta s, this is the angle between the resultant force and the normal reaction. So instead of limiting friction, so this is the case of limiting friction, and the resultant P, this is the resultant P, which is the resultant between R and Fs. The angle made by the reaction force R and resultant P, that is called as angle of friction. So from this diagram I can write tan theta s is equals to, that is opposite by adjacent, so it is Fs by R. But we know Fs by R is already, it is mu s, that is coefficient of static friction. So from that I can write tan theta s, that is equals to mu s, that is coefficient of static friction. Now we will see about the angle of repose. So here there is an inclined plane which is inclined at an angle theta with the horizontal. So what is angle of repose? The minimum angle of inclination of a plane with the horizontal theta, that is horizontal, that is the angle at which a body placed on it just begins to slide over is called as angle of repose. So what is this angle? Okay, this minimum angle for which the body can start sliding. So that is what is angle of repose. If you still increase the angle like this, if you still increase, the body will fall easily. So we have to find the minimum angle for which the body is going to start sliding. So that is angle of repose. So from this diagram, free body, we can draw a free body diagram. So mg acts vertically downwards, and this way it is mg sine theta, and this is mg cos theta. And as the relative motion will be towards this way, the friction will opposite, so it will be in this direction, and the reaction force because of this floor is towards that side. Okay, so now take this way. In this direction you are going to apply Newton's laws of motion. So in this direction, so we can say it is just beginning to move. Okay, so yes, Fs is equals to mg sine theta. So these two forces balance each other. Similarly, these two forces will also balance each other. R is equals to mg cos theta. We have already seen Fs is equals to mu s into R. So from this one, yes, mu s into R, that is Fs. So we are substituting this here, and mg sin theta. So that we are getting R is equals to mg, sorry, mu s into R equals to mg sin theta, and we have another equation, R is equals to mg cos theta. So we are just dividing these two. So we are getting mu s is equals to tan theta s. So again, the tangent of angle of repose, that is equals to coefficient of static friction. Please remember this result also. What is sliding friction? When a body slides over a surface, then the friction between their contact surfaces is called as sliding friction. What about rolling friction? This comes into play when a body such as wheel or disc or cylinder rolls down over a surface. So at that time this will play. And we should know another result, that is coefficient of rolling friction is lesser than coefficient of kinetic friction, which is lesser than coefficient of static friction, or the coefficient of static friction has the maximum value. So please remember this result. So the reason for rolling friction being much lesser than any other friction is because only a very small portion of a moving wheel is in contact with the ground at any instant. So this portion is momentarily at rest. So there is no work is done against friction. So that is the reason for lesser amount of rolling friction. Now let us see about the pulling. So here we have an object, and we are going to pull that object with a force F, and so that this body starts moving. And yes, let us see how is that frictional force and all. So we are drawing the free body diagram. So this is the force F, and the angle made by the force F with the vertical is theta. So I am resolving F into two components. So this is F cos theta, and this is F sin theta. And because of weight, there is mg acting vertically downwards, and the reaction force acts vertically upwards. Now what about frictional force? So I am pulling the object towards this side, so the object will move this side, so the frictional force is towards this side, that is Fs. Okay, yes, so this is the case. Now let us frame the equations. So you see along the vertical side, so R1 is acting vertically upwards, and F cos theta is acting vertically upwards, and mg is acting vertically downwards. So these forces balance each other. So the upward forces, sum of upward forces is equals to downward force. So R1 plus F cos theta equals to mg. Now from this I can write R1 is equals to mg minus F cos theta. And I also know Fs is equals to mu s into R1. So this is the formula for frictional force. So from the value of R1, what I get, mg minus F cos theta, I am substituting this one here in the frictional force. So what is the frictional force? Fs is equals to mu s into mg minus F cos theta. So this is how I find the frictional force in case of pulling. Now let us see the case of pushing. So we are going to push the object. So this is an object and we are pushing it. Okay. Now the angle made by this force F with the vertical is theta. Now we are resolving it into components. So this is the O center point, and this is F, and this is R2 reaction force, and this is mg, and here we are going to make the object move this side. So the frictional force will be towards like right side. So F dash S, I have just taken to differentiate it. So for pulling I have taken Fs, and for pushing I am taking it as F dash S. Okay. Now how am I resolving F into components? So you see this is F, and if this is theta, then this is alternate angle. So this should also be theta. So I have made it that is also theta. And now this is F. So this component is F cos theta, and this component is F sin theta. So this is what I have told here. This F cos theta I have represented it here with an arrow downwards, and this F sin theta I have represented it here. Okay, so that is how we are resolving it into components. Now let us frame the equations. R2 equals to F cos theta plus mg. Why? Because R2 is the only one acting vertically upwards. F cos theta and mg are acting downwards, and these forces balance each other. So R2 equals to F cos theta plus mg. Please remember one more thing. So here we are taking a condition or where the roller is being tried to push or pull. Okay, it is not actually moving, it is tried to push or pull. Please remember that with some force. Yes, now from this R2 have get the, that is F cos theta plus mg, and F dash S is, we know, mus into R2. So F dash is equals to mus into F cos theta plus mg. So in case of pulling, if you see the frictional force, the value of static frictional force is equals to mus into mg minus F cos theta. But here if it is F cos theta plus mg. So what does it says? It definitely says Fs dash is greater than Fs. That means here we are adding these two terms, but here we are subtracting some quantity. So definitely this value should be lesser. So if Fs dash is greater than Fs, that means the frictional force in case of pulling is if frictional force in case of pushing is larger than in case of pulling. So that I can say it is easier to pull an object than to push the object.